All right, let's jump right in. You ever look at some big number and wonder if it's divisible by something like, say, 11? Well, today we're going to crack the secret code of the number 11, and we're going to do it with a math shortcut that honestly feels a little bit like magic.
So let me ask you this. Is 352 divisible by 11? Now sure, you could pull out your phone and use the calculator, or you could even do some long division if you're feeling a little old school. But come on, that's boring. So boring. There is a much cooler way to figure this out.
In fact, there are actually two different, really clever tricks we can use. And you can think of them as these little math magic tricks that don't just give you the answer. They actually show you something really fascinating about how our whole base 10 number system is put together.
Okay, let's start with trick number 1. We'll call it the subtraction trick. It's so simple. You take our number, 352. First, you just grab the last digit, which is a 2. Then you take the rest of the number, 35. Now you just subtract the first from the second. 35 minus 2 gives you 33. And hey, we all know 33 is divisible by 11, right? So that means our original number, 352, is 2. That's it.
Now for trick number 2, the alternating sum. Let's try it on a bigger number this time. How about 8,470? Now this one feels a little weird at first, but just stick with me. You start from the right-hand side and you just alternately subtract and add the digits. So we get 0, minus 7, plus 4, minus 8, which equals negative 11. Now is negative 11 divisible by 11? You bet it is. So 8,470 is divisible by 11. And here's a fun little side note. It actually doesn't matter if you start from the right or the left, as long as you're consistent.
So we have these two tricks that just work. One where you subtract the last digit, and another with this weird plus minus thing. It feels like magic, doesn't it? But you know this isn't actually magic. So how does it really work? What's the secret going on behind the curtain?
Well, the secret, the entire engine that makes these tricks run, is a really beautiful idea in math called modular arithmetic. I know it sounds super fancy, but it's really just a special way of thinking about remainders. And it's exactly what we need to unlock this whole puzzle.
Now, when mathematicians talk about this stuff, they use this special notation. It can look a little intimidating at first, but let's just break it down together. You would read that out loud as A is congruent to B modulo 11. And all that modulo 11 part means is that we're playing in a little sandbox where we only care about the remainders you get when you divide by 11. It's simpler than it looks, I promise.
So here's all it really means, in plain English. That whole A is congruent to B mod 11 thing, it just means that if you subtract B from A, the answer you get will be a multiple of 11. So for example, is 47 congruent to 3 mod 11? Well, what's 47 minus 3? It's 44. And is 44 a multiple of 11? Yep, so the answer is yes. See? That's all there is to it. It just means they have the same remainder when you divide by 11. Okay, now this right here, this is it. This is the single most important fact for this entire explainer. Everything, and I mean everything, boils down to this one simple truth. In the world of mod 11, the number 10 behaves exactly like the number -1. And it makes sense, right? 10 minus -1 is 11, which fits our rule perfectly. This one little equation is the key that makes both of our tricks work. All right, we have our secret key. 10 is the same as -1. So now we can finally connect all the dots and see exactly why these tricks aren't magic at all. They're just really clever logic. Okay, let's go back to our first trick, the subtraction one. Any number, we can just call it n, can be broken down like this. 10 times some number y plus f, where f is just that final digit. So for 352, y would be 35 and f would be 2. So 352 is just 10 times 35 plus 2. And here's where our secret key comes into play. In our mod 11 world, we can just swap that 10 for a -1. So our number, 10y plus f, suddenly starts behaving just like -y plus f. Now, checking if -y plus f is a multiple of 11 is mathematically the exact same thing as checking if the positive version, y minus f, is a multiple of 11. And look at that! Y minus f is the rest of the number minus the last digit. That's our subtraction trick.
So, what about the second trick, that alternating sum thing? Well, as you can probably guess, it also comes from our key fact, but this time it's about what happens when you start raising 10 to different powers.
Just look at this incredible pattern. In mod 11, 10 to the power of 0 is of course 1. Then 10 to the power of 1 is minus 1. Then 10 squared is 100, which is just 1 more than 99, so it's congruent to 1. And 10 cubed is minus 1 again. Do you see it? The place values in our number system, the ones, tens, hundreds, thousands, in mod 11, they behave like an alternating pattern of +1, -1, +1, -1, all the way up.
So when we go back to our example, 8,470, that alternating sum trick isn't random at all. We're actually just multiplying each digit by its special mod 11 place value. The 0 is in the +1 spot, the 7 is in the -1 spot, the 4 in the +1 spot, and the 8 in the -1 spot. The sum of all that, that's the trick.
And there you have it. These two tricks looked totally different when we started, but it turns out they're just two sides of the very same coin. They're both just these really elegant shortcuts that pop out of this one simple, powerful fact of remainder math.
But the fun with the number 11 doesn't stop there. I mean, now that we've totally blown the cover on its divisibility secret, let's look at a few other bits of magic this number has up its sleeve. You have to check out the pattern you get when you divide by 11. 1 divided by 11 is 0.09 repeating. 2 divided by 11 is 0.18 repeating. 3 divided by 11 is 0.27 repeating. The two digits that repeat are always just the numerator multiplied by 9. How cool is that?
Oh, and here's a classic mental math trick. If you want to multiply any two-digit number by 11, you just add the two digits together and stick that sum right in the middle. So for a number like 41, you add 4 plus 1, you get 5, and you put that 5 in the middle to get 451. It's really that easy.
And the powers of 11, they create these beautiful, symmetrical patterns. For instance, 11 squared is 121. Notice that? It's a perfect palindrome. It reads the same forwards and backwards. And the pattern just keeps going. 11 cubed is 1,331. Another perfect palindrome. It's just a fantastic little quirk of numbers.
But here's the real kicker. Look at those numbers again. 1, 11, 121, 1331. Those are the first few rows of Pascal's triangle. That incredible connection keeps going until the numbers in a row of the triangle get bigger than 9, and then you have to start carrying over digits. Just amazing.
You know, when you get right down to it, all of this shows us that modular arithmetic is so much more than just a party trick. It's a powerful way of looking at numbers that lets us find all these hidden structures in our number system. It's an elegant way to reveal these beautiful patterns that are hiding just beneath the surface of the numbers we use every single day.
Which really just leaves us with one last question. We just uncovered the secret code for the number 11. But that makes you wonder, doesn't it? What other number secrets are out there, hiding in plain sight, just waiting for us to find them?